New Flow language features for React. If somehow you're not familiar with Flow, there used to be a war between Flow and TypeScript, and obviously Flow won. That's a joke. TypeScript won so hard that Flow ended up not really being traditional open source anymore. They pulled it back into Facebook because Flow was by Facebook, and now it's mostly maintained internally. I think the code is still public, but it's no longer open source in the sense that they're not taking contributions. They're not really considering issues that others have, but they are using it as a sandbox for figuring out how to do big, massive scale JavaScript inside of Facebook, especially for React. And now that Influence is doing interesting things. Specifically, they're building language features into Flow that are specific to React. What do I mean? Well, let's take a look. Write safer and more succinct React with Flow. Y'all notice something interesting about this? This looks just like TypeScript for the most part, but there is one part that is very different. Notice the word here. It's not export default const or export default function. They added a component keyword. Very interesting. We have thousands of engineers committing React code every day to Meta's largest code bases. Part of our responsibility on the Flow team is to make it as easy as possible for anyone to contribute. From design system React experts to C++ engineers making one-off internal pages to support their backend services. Over the last year, we've built several new language features to make it easier than ever to write high-quality React code. And we've built powerful new tools for design system owners to express their design constraints in the type system itself. This is a really cool piece here. There's a lot that makes this interesting, but y'all will get it as we go through. It's really cool. Flow is excited to announce component syntax, adding first-class support for React primitives such as components and hooks to the Flow language. These features bring improved ergonomics, expressiveness, and static enforcement for many of the rules of React. They've been updating and really refining this rules of React page. They actually, if I recall, have a full blog post deep dive planned as well. I will give the context of I've been talking with the React and Flow teams a bit, trying to make sure how we communicate these things because they are really, really cool concepts. One of the things that stood out to me was how much better they said they understand React rules since they started working on this. Obviously, with the React compiler coming up, the React rules have stopped being a nice thing for React performance and a necessary thing for these optimizations. As they've built things like this, as they've built things like the compiler, they've realized that they didn't even necessarily fully understand those rules and how they impact things. And through building this stuff, their understanding and framework for these rules has gotten even stronger. And what I'm excited about with this is they're not necessarily going to force us all to deeply understand these rules, but they can encode them in things like linters and things like the language and things like the compiler so that we can get better at React through what they've learned shipping React at insane scales at Facebook. We've already adopted the component syntax across all our code bases at Meta, and the results have been incredible. We've seen a massive reduction in boilerplate for writing components, we've caught thousands of violations of the rules of React, and we've seen design systems codify their stylistic rules in the type system. Most importantly, our engineers love the new features. We're excited to share these features with the broader community. If you're already using React in your own Flow projects, you can enable these features by upgrading to the new version of Flow, 0.233. None of this is required to use React, but if you're already using Flow, these features may be interesting to you. It was funny. The way that this was pitched to me by Eli was, hey, Theo, we're working on a cool thing. We'd love your thoughts on it. By the way, you cannot use this thing. Just know that going in. And I can't use this. I'm not using Flow. I'm sorry. We might try it in a bit, but I'm not a Flow guy for sure. Component syntax features. This is a part that's really cool too. We'll get to that in a bit. But there are a couple core new features with this model. We have a new component declaration. Instead of function or const, you call component. It's a dedicated syntax for defining components that is ergonomic to use, reduces boilerplate code, and it provides a greater safety by enabling many and enforcing many of the rules of React. There's also the new hook declaration, which is really cool. No more lint rules that look at the word use and make a bunch of weird ESLint changes as a result. Now you can actually declare a function as a hook directly. This is a dedicated syntax for defining hooks that provides additional safety by enforcing the rules of hooks. There's a lot of rules to hooks if you don't already know, things like making sure you don't put it under a condition because it changes the way that things render and the order that they're bound. That's now much easier to enforce at a language level if you have a syntax that indicates what it is. We also have statically enforced design system rules with render types, which is a really handy thing. Render types, you can think of this as if I have a badge component and I want to make sure you're passing text to it, you can enforce that using these types, which is cool because that was never particularly easy to do with React, and in Flow it is now trivial. We've introduced render types, a powerful tool for design systems that makes it simple to express stylistic constraints through types. That's cool stuff. So let's take a tour of this code. Here is what this code looked like before. Again, this is Flow. It looks a lot like TypeScript, but it isn't TypeScript. The $ read-only syntax and all of this, it is what it is. So this is how you define the props. And then you define the function hello world. It has text hello on click, which is typed as props. This is a react.mixed element, so it's an element that can return all sorts of stuff. With the new syntax, way simpler. export default component, hello world. And now this is so nice. Y'all who have been in TypeScript for a while, hell, I think during my tutorial, I ran into some annoyances where if I broke out the values, I had to retype them all in order to have them. Like, it's a silly thing, but if I just like function some button and I want this to take in, I don't know, text as well as a child, I could do children text, but then I have to type this. So I have to go again, children React node text string. And now I have like everything I wanted, but I had to retype it multiple times, which is just obnoxious to have children and text. Usually as a result, I put props here so that I just have everything there. And then when I need it, I'll do props.text later. But that's like just a quirk of how type definitions work when you're also breaking things out. It just always felt really tedious and annoying that I had to write children and text twice. Not because like writing things a bunch is annoying, but changing them, maintaining them, having consistency between them, it was more tedious than it needed to be. Because you can't pass multiple props to a component anyways. Like I couldn't have another prop of string. Like you can't do that. With React components, when you're mounting them in JSX, everything you pass gets put into a single prop object. Because of that, you have to use an object for what you're passing into the component. This is doing that under the hood for you. Like there's a compiler step that turns this into a single object, but it makes the syntax for managing this all significantly cleaner. I actually like this a lot. Good stuff. Let's take a look at the basics. As you can see, components are quite similar to functions, but with a few differences. They replace the function keyword with component, using individual params instead of a prop object, which is specifying default values in line 2, which is actually really nice. It removes the duplication required when using object destructuring and removes the need for modifiers like read-only. Yeah, there's just a lot of boilerplate that gets killed by this. It seems like not that big a deal, but when you have a massive code base and you have like lots of components all over the place, anything like this you can do to meaningfully simplify things is a massive reduction in the amount of code. They also killed the need for return types, which is really nice. Flutter's always been kind of big on return types, but now that can be inferred through the component syntax, which is really cool. Makes Flow, in my opinion, significantly more usable. Flow enforces the return value will always be a subtype of React.node. So if you return something that wasn't valid, like JSX or a React node, like an object, this will throw an error now at the compiler level for you, which is really cool. Full compatibility. Components are designed to fully replace their functional counterparts. To achieve this, we've added a few more features to support all prop types, including REST parameters and props that use invalid JavaScript identifiers, as with HTML data attributes. So you can have data test ID as test ID string, other props. Yeah, that's really cool. Now you can get all these things quickly and trivially pass them around. Really solid syntax. One underappreciated thing here is the standardization of the syntax. As I was showing here, there's a lot of different ways we can type this. We can have like the direct type here with props. We could destructure it with children. We could do children.rest or props. There's a lot of different ways that we can structure and destructure this. And if you have a large team of people with lots of different opinions on how to do this, your code base might have the exact same code written like 15 different times with slightly different syntax. You might have props like this. You might have one where type button props equals that, and then you pass this instead. There's so many different ways that you can type your components and your props. And because the prop syntax is so open, we end up seeing lots of different syntax in our code bases. It's pretty common that I'll be working on something with someone else and we just write our props entirely differently, which is, I don't want to say like a mess because it's not the worst thing in the world, but it is definitely a little more annoying when doing code review, and especially for new contributors joining a code base and seeing that there's 5 different ways to type props. It can be very nerve-wracking, especially for earlier devs or devs that aren't as familiar with React when they see 15 different ways to do the exact same thing. This significantly shortens and like reduces the range of different options. It kind of reminds me of like the built-in formatter in Go, where there's just one way to write Go. This is nice that they're kind of doing the same thing where there's one way to write props now. There's a bunch of variation within it. Like you can do the triple dot spread like this, but I don't think that'll be very common when it's this easy to just write out the object now. So actually digging this quite a bit. What if you want to reuse prop types as a whole? I will make the argument that this isn't very common. What I do see that's somewhat common is you want to pass props down from a parent to a child, which they actually show in here where other props gets dumped on this div. This is, I think, the use case where I would see a lot of that, where like I have something that's wrapping like a badge and I'm putting something in the badge, but I also want to pass all the original badge props. I could put the props that are specific to my component and then have the rest be typed through this collection thing. So I can pass that down the rest of the way, which is actually really, really convenient for that. And I also think it's more explicit in the instances where you want to do that. So anything that's specific to this component, you'd put above, and then anything you want to pass through, because this thing that you're rendering has its own types, you could either give it its own key of like badge props, badge props, or you could do this collection at the end like we're doing here. I actually think this covers all of those cases really well. Like I'm looking for holes to poke because y'all know I don't love flow. I really don't love flow, but this is better than I expected. I like quite a bit. String props are allowed, but they must be renamed via as. That's cool because like this is a string, so we can't directly access this in JS, even though that's how it was passed through the JSX and HTML layer. So the as lets you actually get the value out from that. And then at a compiler level, that's all handled. Pretty cool stuff. And creating prop objects via REST params is also supported. So that's that guy. Good stuff. Improved safety. Beyond the obvious syntactic advantages, component syntax also introduces new capabilities that allow Flow to better understand your code and enforce React best practices to help avoid common pitfalls. The next section will cover a few of these features. Ensuring props are deep read-only. One of the basic rules of React is that a component's props shouldn't be mutated. I actually cover this in a video that I did recently where I show how bad things are if you like accidentally reset or reverse a list that's passed as a property. The fact that it's hard to guarantee that is obnoxious, that like you're not accidentally going to write things. Strict React rules prevent it by doing weird cloning stuff, but it's still not great. Ideally, your compiler would enforce that you're not actually changing any of these things. And now that can be enforced. Historically, this behavior has been partially enforced with the common practice of wrapping prop types with read-only. At least this is common in Flow, not common in TypeScript. With component syntax, all props are checked to ensure they aren't mutated during render. Huge. This means you won't need to add the read-only anymore, including on REST props. You'll get additional flow coverage. Yep, cool. Here we see what this looks like. We have a type, item name, type other props, user ID. Normally you'd have to mark these as read-only, but as soon as you make them props for a component, they automatically become read-only. And you'll get an error when you try to reassign them. So like error, React rule, unsafe mutation, error, React rule, unsafe mutation, error, deep checking caches, error through copied output. That's also really cool. If you copy the object, you'll still get an error. The last error above was particularly exciting for us to catch. We've seen many cases where the programmer clearly understood the rules of React and would copy objects instead of mutating them directly, but they would still erroneously mutate values that were only aliased, not copied. Immutability can be subtle, even for experienced devs. Yeah. So in this example, the user item of type item, when we dump like this, it's still referencing the old values. So if we were to try and change things there, that could hit the reference value instead. This feature helps prevent a common class of bugs while removing the need for boilerplate that was previously universal. This feature does have its limits though. At present, Flow is only able to detect mutations of props in a component or hook, and we optimistically assume the method calls do not cause mutations. So if you had like a function in here that you were calling that did all of these things and you passed the prop to that, it could still have issues. So that's the remaining edge case that is being discussed here. But still a massive win. I will say edge cases like this kind of scare me because once something like this gives you the confidence that you can't accidentally mutate, and then you have that edge case that allows that, this is going to result in people thinking less about the rules of React in the sense that like they don't have to worry about it anymore. They get an error if they accidentally mutate. They don't think about it anymore. And then they go and accidentally mutate this other way that's more obscure. That's a tiny bit scary to me, but also understandable restriction. Be cool to see if they can enforce that in the future. Enforcing best practices with refs. Oh boy, refs, everyone's favorite, especially in React. Thankfully, refs are getting an overhaul soon, but let's see what they've done for Flow for now. Enforcing best practices with refs. Another pattern we enforce in component bodies is that refs are not read or written during render. This is another common pitfall that can lead to unintended behaviors. Check out the React docs for more information. Here's an example of this in action. So we make a ref, render counter, use ref, render count.current plus equals 1. This should happen in things like effects or on clicks, but this should not be part of rendering. That causes a lot of potential issues. And then we get an error when we try to render it. Interesting. In order to safely use refs in your components, you can read or write to refs from event handlers or effects instead. So if we want to access the value from the ref, we can't just render it. We have to throw it in state. And then we have a use effect on the ref to update the state. Yeah. Nice to see this type of thing being enforced now at a compiler level. It's surprisingly common that people do this wrong. I know I even do. In total, these features make it easier for programmers and reviewers to focus on the business logic instead of writing bug-free code. I like this a lot. This is something I push for everywhere I can. This is another reason why I just like stuff like TypeScript. The likelihood that you write a lot of these simple bugs that you have to look for constantly is much lower. I know that before TypeScript, I had been trained to look for what effectively were like small typos and one-off tiny mistakes. And with React, I've had to look for things like this, like, hey, should we be dumping this value the place we're dumping it? Or Are we passing things and modifying them in a way that we shouldn't? Now, with a language level guarantee, those are things I don't have to think about as much, and I can focus on what the code's actually doing, not the edge cases that it happens to stumble into. Now let's take a look at the hook syntax, which honestly is even more exciting in a lot of ways. Hooks are another fundamental abstraction in React that can benefit from improved type checking validation. We've introduced the hook keyword that can be used in place of function when declaring custom hooks. This allows Flow to enforce that hooks adhere to the React programming model. Hooks must be called in the same order on every render. This is an important piece. I've talked a bit about this before. The TLDR is that hooks are basically indexed at the component level. So if the order they're in changes, it doesn't know which hook is assigned where. Hooks also must operate under the same restrictions as component bodies, such as not reading the ref.current or mutating any past values in parameters. When called, hooks must obey that use_foo naming convention. For example, use _foo or my hook would lead to a flow error. That's nice, that when you define something using the hook syntax, if you don't name it properly, you get an error. As the converse of the above, non-hook functions used within components or other hooks should not have names that match the use_foo pattern. Again, very nice. I've seen old libraries that came out before React that had the use syntax as just like how they named things. And I've even wanted to name things like that too, and could easily lead to issues. Many of these rules are already enforced with the ESLint React plugin, but we also apply the validations discussed in the component section to hooks. As you can see from the example below, the only change necessary to adopt the hook syntax is to replace function with hook. So literally take function, change it to hook, and you're done. Check out the hook docs for more info. Is that the hook flow docs? Yes, it is. Good to know. We also now have render types, which are a really cool new thing. Render types are a powerful new feature, providing an ergonomic way to define how components should be composed. We designed render types to make working with component libraries safer and easier. At its core, render types consist of a new renders type annotation that can be used to specify what a component ultimately renders. Here's an example. We have export component layout. It has a header, which renders header, which is a component type that we have above here. Export component header. There you go. So library component can specify what props should render. So now this needs to pass header, and I'm assuming if it doesn't, we get yelled at. Component my header renders header. Also really cool is if you have your own custom component that wraps header, like my header, and this is where it gets magical. If we composed something around header, and then we want to use that as a prop for layout, now we can. This is so cool to have like the header type from this return hydrate up so that when we pass my header to layout, it knows that the result of this is that it renders header. This is really, really cool. This is, I can already see our resident design system guy, Igor, freaking out. He wants this in TS so much. Yep. Anybody who's built component libraries knows how insanely valuable this can be. Remember, not everyone at Meta who needs to write React code is a front-end expert. Again, huge deal. I have a whole video about this. I call it the average React dev. And yes, that applies even at Meta. Most React devs have never started a React project. Most React devs haven't debugged really complex like edge cases around hooks. Most React devs don't even know the rules of hooks because most React devs are working at a company that's been using React for years that was started by somebody a long time ago that might not even work at the company anymore. And they're just contributing to the code base or making a quick change. They shouldn't have to know all of these things. And the more that we can implement them at a language and linter level, the more likely that these errors come up in their IDE as they're making them, the less you have to learn to be productive in React. And the goal here isn't to make everyone a React expert, it's to keep a React expert from being a necessary dependency in your review chain when somebody's going to make some small changes. Really, really cool thing. And I like that they're calling this out here. Design systems make it easy for people with relatively little experience to make beautiful, cohesive UIs. Render types let the design system owner codify their design rules in the type system itself, which helps all the downstream users build even more delightful experiences without having to know much about UX or UI design. That's really cool that through the flow types, designers can now enforce backend devs write code that results in less ugly UIs. That's huge. I see Igor freaking out in chat over this, which makes sense. This fits him and his goals perfectly. With render types, you can also describe optional rendering or rendering a list of items with the renders or the renders star variants. That's pretty cool. You can also use component names as shorthand for easily referring to component types. For example, header is equivalent to react.element type of header. Check out the render types documentation for a lot more info about all of this. You can also try it out. They even have an example app, so stick around so we can give that a shot. Oh shit, they're using Vite for that. Is this the first official React Facebook world Vite thing? It's cool seeing like Vite plus React plus Flow. What a combination. Oh damn, example. It's time to play. They couldn't help themselves. They still used Yarn. I get it. I understand. I will admit, having done a lot of Next dev lately, seeing the page load immediately first try is actually really nice. Okay, so we have the use counter hook. We have component app. I change this to function. will still behave. Cannot build the typed inference for this module. You should annotate. Is React element not a type for this? I don't even know what the default types are. Cool. So we're just going to use the component syntax for that instead. Component app, cool. Use counter, return, v React flow. Nice. So what happens if I just do this the wrong way? Const sum content equals div hi. Cool. It's immediately mad at me because it's assigned but never read. Cool. We'll read it. We'll read it down here. Gonna delete everything here. Cool. And that works. I'm guessing this is very easy for it to infer. It's react.jsx.elements the type. So I change this to function app react.jsx.element. No? Is this react.element? Requires additional stuff. Cool. We don't care. I'm already seeing why this is so useful. That makes life much easier. So we have this hook. We have this here. What happens if I wrap this in a condition? So if true, let's do a crappy one. Cool. I just want to see what this error is. Component calls cannot be called via conditional contexts. Look at that. How cool is that? I changed this to be function. Well, I still get the same error. Nope, look at that. See the error changed? I no longer get the use error because we don't even have linting set up here. This is purely the type system that is enforcing that, which is really, really cool. Just changing this from function to hook. Now we get this error that tells us cannot call hook because React hooks cannot be called inside of conditional contexts. That's really nice. I can see why we should all probably be using this. Yeah, I want this in TypeScript and I want it in TypeScript now. That's going to be tough though. I'm going to show something a bit interesting. Let's go to npm trends. We're going to look at the TypeScript as well as React. And we're going to look at it over all time. What you'll notice is for quite a while, especially early on, React was a decent bit more popular than TypeScript. I know that sounds insane in retrospect, but for quite a while, React was growing a bit faster and was also a bit larger than TypeScript. Obviously, that's not the case now, but at the time it was, which was even crazier when you consider the fact that React was largely leaning into Flow and the ecosystem was TypeScript. React was still beating out TypeScript for adoption due to a large number of things, including the standardization of TypeScript as like the go-to language, including most React devs using TypeScript now, including the just universal adoption of TS as a language. We have seen this gap emerge. Now imagine that you're one of the TypeScript maintainers or you're the people on the TypeScript team that decide what they do and don't support. If you're back in this area where the running is close, but React is more popular, and this new JSX syntax comes out, and all the React devs aren't going to use your language unless you support it, that ends up resulting in TypeScript kind of being inherently pressured by the forces around them to support JSX and to support all of these things that we now rely on in the React world. If this new syntax was introduced at this point in time, my honest guess is that it would have been adopted by TypeScript, just so that there was more reasons for React devs to go to TypeScript instead of Flow. On top of that, other frameworks would have a huge advantage too. Like Solid wouldn't exist if it wasn't for the fact that JSX was put into TypeScript. And when new things like bundler changes for use client and use server appear inside of common tooling, frameworks like Solid can just hook into that and use it for their own things. Now that there's such a big gap between TypeScript and React adoption, the likelihood that the TypeScript team is going to make significant changes and introduce significant features, like an alternative way to define functions, is significantly less, just because if they don't, what happens? Is TypeScript going to have actual adoption issues if people don't have this new syntax that they kind of want? It's very unlikely. So how do we convince TypeScript to add this? That's a really good and honestly kind of scary question that I've been thinking a lot about because I want the syntax. This is obviously much better. I want this. So how do we get this inside of what we're doing now? There's a lot of hacks we could do. Like one option that comes to mind is similar to JSDoc. We could have some type here that's like at React component, and then some third-party compiler or checker that can abstract this and realize what it's doing. Obviously, though, the syntax isn't great, especially compared to how simple it was in Flow if you just do components here instead. So I'm a little scared that what solutions we might hack in will end up adding complexity on top instead of reducing complexity at the lower levels like we're hoping for. Somebody made an interesting point in chat already of, can't one write a TypeScript compiler plugin to do that? Not really. TypeScript compiler plugins add default types effectively. So if I wanted to write a compiler plugin, I could write one that adds a bunch of globals so that I have access to types everywhere. But with a TypeScript plugin, you can't change what function is and write a custom thing for that. Not really a great path there. What we could do though, which would be a crazy mind-boggling hack, would be using something like a TypeScript plugin in combination with Flow to transpile our React code to Flow, check it there, and then spit back the results in our IDE. It's an absolute insane way of chaining things together, but it's honestly a kind of exciting future that I could see a lot of potential in. You might have to use syntax hacks, like when you see a function that's defined as use something, then you auto in that checker, change function to hook, pass it through the checks, and then spit out the results. And same with components. If you have a function that is a capital letter and takes 0 to 1 object props, then you'd be able to throw that in, know that it's a component, do all the checks accordingly, and spit that back. There's a lot of potential ways to hack this functionality into TypeScript, but it would be really nice if we didn't have to. But when you look at this, it seems like we will. It just seems increasingly unlikely that TypeScript will make changes for what the React world wants, which is not how things used to be, sadly. Doesn't mean I don't really want the syntax, though, because damn, now that I've seen it and I've actually played with it and immediately seen the difference, this is dope. And I want this. And I want this now. So, yeah. What do you guys think? Is this cool or is this crazy? Are you suddenly more interested in Flow, or do you just want these features to come to TypeScript? Let me know in the comments. Until next time, peace, nerds.